it's Hannah here, and you are watching Kiss Crew Chemistry Help, where we make chemistry more concrete so that you can succeed. Today I want to talk to you about a trip that I actually took last April with the Boiler Green Initiative down to Chicago. We actually went on a trip where we went to the Nike store and recycled a bunch of shoes that we had collected from a shoe drive earlier that year. The result was fabulous, actually. Everybody in the Nike store was super excited about us. In fact, they even featured us in an article and they got our picture. And then we got to mess around with the DJ who was rocking it. He was pumping up the jams up in the Nike store, and it was a really great time. But another thing that I noticed as we were making our way through Chicago and seeing some of the sites was just the sheer amount of rust I observed on things like train cars and the railway stations and even buildings and some sculptures like the lion sculpture in the front of the Art Institute of Chicago. So I wanted to talk to you guys today about the chemistry behind acid rain, because acid rain is what contributes to that rust formation that you see on all those buildings and structures, and it's actually a result of a lot of human activity. So let me talk to you a little bit about, first of all, where does acid rain come from? Acid rain actually comes from a variety of sources, namely, for the Chicago area, it comes from heavy manufacturing, it comes from power plant exhaust, it comes from car exhaust due to the high amount of traffic that happens during the rush hours. So what basically is in common with all three of these different sources is that carbon dioxide gas is produced. And in the formation of carbon dioxide gas, it comes in contact with water vapor in the air, and then when times happen where it's going to rain, that water vapor has already had its pH changed to a more acidic form by the formation of carbonic acid in the water. And the carbonic acid actually forms in this reaction. Carbon dioxide gas plus H2O, which is water, gives us carbonic acid, H2CO3. So once this acid has been formed in the water, and it is soluble in the water because it's part of it, is coming from the water and it is still soluble, the acid actually catalyzes rust formation on surfaces when the rain comes in contact with the buildings and the structures and the sculptures and the railway stations. So what I actually wanted to do was give a quick and easy experiment to model how this pH change is actually observed, because you might be a little bit thinking, well, where is your proof that this carbon dioxide gas is actually contributing to acid rain and this isn't just coming out of your head? Well, let me show you experimentally how you can create acid in the presence of water with the presence of carbon dioxide gas. So here we go. I started by taking 4 different concentrations of sodium hydroxide, which I form out of serial dilutions in this video that I'm linking up above, and I proceeded to fill 4 wells each with each of the solutions. So going down, as you see it from left to right on the screen, I am going from the least concentrated solution to the most concentrated solution. So you'll see here in a second when I add universal indicator how the pH is different from the left side to the right side. As you can see, the pH gets higher as you go from left to right because the strength of the base in the solution is higher on the right. Now I put it into a Ziploc bag and I proceeded to close all but like about a ½ inch, and then I injected my carbon dioxide gas. And then I proceeded to seal it up as quickly as possible and proceeded to do a time lapse on it so you can see it changing color. Now with the universal indicator, as you go more purple, you are more basic. As you go to green, you are neutral, and as you go orange to red, you are increasingly acidic. So you can see here that acid is actually forming because the pH is going down lower and lower from left to right. You can see that it's least affected on the right side because that's where the most basic solution is, so there would be the most base ions to neutralize with the acid. However, on the left side there are the fewest base ions to neutralize with the acid, so you see more orange and red colors. And that's it for the video today, guys. So you've seen how carbon dioxide actually, in the presence of water, forms carbonic acid, which then forms acid rain, which then catalyzes rust formation, leading to the rust that you see in big cities like Chicago or LA. Alright guys, that's it for the video today. I'm going to leave you with some very satisfying Chicago B-roll. If you liked what you saw today, please like and subscribe to my channel. I put up new content about every other Thursday, and although I'm a little bit off from that schedule lately, it is my intention to come back to that schedule of about every other Thursday posting new content. So please stay engaged, and I hope that you are having great success in your journey throughout your chemistry courses, whether it be general chemistry or organic chemistry. If you'd like, go ahead and post any suggestions you have for what might be a useful topic you'd like to have covered in an upcoming video, and I'll see if I can work that into my schedule and create that for you, because ideally I want this KISS Crew community to be as helpful for you as possible. Thank you so much for watching, guys, and I hope you have a great rest of your day. Bye!